Hey guys, hello and welcome to a new video. This time again an Excel Esports case by one of our guys from Madagascar. It was a cool case. Level 7 and bonus 5 were super hard. Level 5 and bonus 5, sorry, there's no level 7. But it is a case that is showing us something new. Something new that was talked about in the last files episode. Yeah, but I will talk about this later. So, what we basically have, we have tunnels between cities, and we want to calculate some distances and so on. So nothing too special. So the kind of a data case, a creative from selection. I also do here a concatenation between city 1 and city 2 because I will use this later for some XLOOKUPs. And since I know that this could be a problem if doing it single cell and not adding there a column, I add the column at the start and also make it non-dynamic because this table will not change. And then we can spare some calculations. Okay, distance between those cities, XLOOKUP, this and this in CC returning distance. This will not find everything. Therefore, we do an XLOOKUP between this and this in CC returning distance. And this will find everything. Okay, here we can basically use this formula again. So we use map. Then I map these two cities and these two cities. Why is Excel so slow or I'm so fast? A, B. And then we do an XLOOKUP A, B, B, A. And we sum this and you get to the same result. Nothing too special. Closest city. So therefore we could do, for example, a filter. So I filter haystack city 1, city 2. If by row and also, sorry, also distance. If by row search this text in haystack city 1, city 2, and then is number uh, is number 4, and here we have it. Now we want to have the minimum distance and then the non-Zagreb city. So let's or sort after the third column, and then we take the first row and the first two columns and we filter D if D is unequal to this city. And then let's simply copy it. Okay, now level 4. I did the single cell. Yes. And not single cell, sorry. I did it with data tables. So. And in this case, we kind of imagine that we drive with trains between those cities. And therefore, I first need the distance. So I can basically copy the formula from here. And then we travel that many kilometers. And if I'm below 100 kilometers, then I take this times 10 as my speed. Otherwise, I take 1000. This is for the acceleration. You see until there. And then I need also something for the deceleration. So if this is large, this minus 100 is larger, no, plus 100 is larger than this. Then I take this minus this. Would this work? No, the other way around. So this here minus this times 10 is 10 plus 1, I think, plus 1, otherwise 1000. And let's take a look. Acceleration still, then up to 1000. And at the end, we're starting to decelerate by 10 kilometers per hour per kilometer. Yeah. And then we divide 1 by all of this, which gives us how many hours it takes us to fulfill this kilometer. And then we simply need to round. Digits. Column input successor. And we have solved level 4. Okay. Now let's first do bonus 1 to 4. How many unique cities are on the list? So rows, unique, vstack, city 1, city 2. Which city has the most tunnels connected to it? So group by vstack. Also the same, so vstack of both cities. And function is count A, sort -2. And we see that it's London. So we basically can also copy this formula in here as a single cell with the intersectional operator. Yeah. How many tunnels are connecting two cities that start with the same letter? So basically minus my sum minus minus left city 1 1 equals left city 2 1 9. How many pair of cities are not connected by a tunnel? So mix two arrays together. Um, I know unique. A VStack, city 1, city 2. That's too much, sorry. No, it needs to be less because I think this lambda does not use the order. So unique VStack city 1, city 2, 2 row. And then we simply in the first instance make it that way. We can also call this. So then I want to text split this. Of course, then I need to track it down, array of array stuff. Then I want to sort it. I call, sorry. I should make it here then. Then we use unique of this. And we still need to say if it shouldn't be the same. And then we can filter. And we have 750 connections. 1770, yeah. Okay, and we take a look. If is number x match or is number x match this and this in CC, or is number x match this and this in CC. True. False. So equals 1770 minus sum of minus of this area here. And it's 1570, which is right. So, and now we need to go to the most interesting part. It's level 5 and bonus 5. So the cities are not connected directly. You can transit by using other cities, and we want to know the minimum distance. And here we need something that was talked about in the latest the Excel files episode, because there it was talked about that we will need more and more like real algorithms, real math and programming algorithms. And yeah, one of the algorithms is the so-called Dijkstra algorithm. Here's a short explanation by ChatGPT. The Dijkstra algorithm finds the shortest path from a starting node to all other nodes in a weighted graph with non-negative edge weights. It works by repeatedly selecting the unvisited node with the smallest known distance from the start updating the distance to its neighbors if shorter paths are found and marking it as visited. This continues until all nodes have been visited or the shortest path to the target is found. So basically what we're saying, we interpret all the cities as nodes and the tunnels as, because we know the distance, as weighted graph, uh, weighted somehow, weighted lines. Yeah, and we do this. So there are multiple methods how to do this in Excel. Some were using the solver, but this is not dynamic or yeah, not that great. I did it first as an data table and track down solution. That solution I will show you now. So data table level 5. How it is. Okay, distance between Manila and Pretoria. So first what we need here is a list of the unique cities. So unique, VStack, city 1, city 2. Then we initialize the visited array with zeros because we have visited no city at the beginning. Then we start with the city Manila. The distance between Manila and any other city is 0, we know this. And then we calculate the distance between Manila and every other city. We therefore use our lambda, but we map in map. No support. I need no support. Lambda A and this city here, this city here, and A. And if not found, then we take something large, 100,000 or 1 million, and yeah, this is then called, we call this dist for distance, and this is then the distance saved. In this first instance, it's the distance, so either 1 million or the distance between Manila and the city if they're connected by a knot. And visited is this plus this city equals to Manila. Yes. And only Manila is then marked as visited. So now we want to know the new minimum distance. So here min of filter every distance if this equals 0. So every distance of an unvisited city, in this case 5,612 kilometers, and it's the distance between New Delhi and Manila. Okay, and then we basically do the same here for New Delhi. So okay, now we can adjust this. So the distance calculation, and now we see, okay, New Delhi and Brasilia, the capital of Brazil, are connected, and so on. But now we need to do something a little bit else, because now we cannot say, okay, it's basically the distance here. We now need to check if the not value plus the new distance. So the distance between any, because this is based on the no, on this, sorry, on the saved distance. So if the distance between the Manila or the new city we are in and the next city we can go to from the city, plus the distance we need from Manila to the city is smaller than the safe distance, then we have a new minimum distance. And therefore we do here if this plus this is smaller than the safe distance, then we use this plus this as the new distance, otherwise it is still the distance saved. Okay, there's something wrong here. Smaller. Okay, yeah. Okay, it's still the distance saved. It's still the distance saved, and here we have a new minimum distance, so to say. So now we also mark this city here, New Delhi as visited. Here you see Manila and New Delhi are marked as visited. And what we now do, I first show this for one. We track this aside. Okay, we have there an error because it was done on the wrong city, on the wrong distance. We need this to make a search on distance saved. But now here this is adjusted correctly. This is adjusted correctly. This also, distance saved, distance marked as visited. Yes. And now we can simply track this aside for all the cities. Okay, we still need to track. Okay, here we get a calculation error, and there we have reached the end. No, have we? Have we visited all 60 cities? No. Okay. Let me check. Ah, okay. Here we should have reached everything. Lima is the last one. No. There's still a few unvisited cities. Ah, but we're getting there. Shouldn't be that many more. Okay, here we've reached. So Mexico City is the last not we visit. And then my result is, because here we have always this is dist saved and visited. And this is basically of interest for us. And there we search for Pretoria. So xlookup for Pretoria in here, returning dist saved of Pretoria. And we get to the same result as searched. And therefore you can basically do a kind of dynamic Dijkstra algorithm with this case in Excel. Okay, let's data table this. We'll calculate shortly. Longer than expected. I hope it will not crash. I hope it will not crash. Okay, here we go. Let's check. Level 5. and everything is fine. So, but I also did something else because both ChatGPT and Gemini were telling me, oh, this is not possible as a single cell. This is not possible. And I wanted to prove them wrong. So I basically packed this in a lambda. Here's the Dijkstra. It's basically the same as this whatever robot. City Dijkstra. Come on. Yeah. Oh, a robot. Okay, so as you can see here, it's basically the algorithm I've done flat with a reduced function as a single cell. Nothing too special there. With reduce, you can do this simply because you have all previous steps in an array and yeah, can do this there. So we can also do this single cell. So here, this is CD8, this is CDB. CD1 is the list here, and CD2 is the list here. Distance list is the distance list. And we then also get our results. Short calculating, and it's also right. So, bonus 5. For bonus 5, I copy the level 5 sheet. And we want to know the minimum amount of nodes between Caracas and Dublin. Caracas, Dublin. And now we simply say, okay, if there is a node, then the distance is 1. Otherwise, so we have here 60 cities, then the distance is 1, otherwise the distance is 10,000, and then we have like a not kind of thing. This will not work. Ah, yes, of course, because I need all concatenations, which are 200. Okay, this is then right, 1 and 1000. We mark this as visited. We need also sequence 200, no step. And then we can basically that's a problem. Yeah, of course. We then cannot use XLOOKUP here. We can simply use add filter this if in this case it doesn't matter. It simply should be unused. No, it matters. Okay. XLOOKUP. So XLOOKUP min and filter if this is 1. Okay. There are 2 ones. Fix lookup filter. Oh, come on. Filter. Filter this if this equals 0. And then we want to have the minimum of this. And there, returning the city name. Great. Why is this not working? Minimum filter this. That's 1. We look for 1 in here. There should be only 1. Returning this. Ah, yeah, of course. I'm so idiotic. Filter this if this equals 0. Otherwise, we have a different length of the array. Okay, it's Beijing. And then we track this aside. Not so. Until we're here. Okay, something is not working. Yeah, of course. I need to fix this here. But then we have the same all visited. And there's still something wrong here. Okay. Again, track this aside. And now we have the number of knots between those cities. And we can then do an X lookup for Dublin in here, returning the number of knots, which is 4. But now we need to read properly only the cities we have to transit to, so the cities between start and finish. And if our number of knots is 4, then it's 4 minus 1. And we can also do this single cell. So Dijkstra min not. City A is, doesn't matter, but Caracas. City 2 is Dublin. Input city 1 and city 2, and distance. And we also get our result. And with this, the case is solved. A little bit over 30 minutes, but I showed you the Dijkstra algorithm in detail. And if anything was wrong, I'm neither a mathematician nor a programmer or a computer scientist. But anyways, thank you for this case. It was super interesting. And it showed us that probably algorithms will take a larger space in Excel Esports in the future because we are evolving. And yeah, we know that the Dijkstra algorithm can be done in single cell approach, which is not known by AI, so we're still in lead, kind of. Thank you for your time. See you next time on my channel. Bye.